Okay, hello everyone. Good morning, good afternoon, good evening, depending on where you are right now. Uh, all this new situation and online sessions changed the conference quite a bit. The experience and people participating. So I guess there are people from all over the world right now. Hello to everyone. Welcome to the session Road to the DevOps. Are we ready for the transformation? My name is Mustafa Toroman. Um, just one second. Okay. Please help this cause, help donate. Conference is in support of UNICEF, and it's basically a fundraiser to fight COVID. Hopefully, we will make some impact, and everything will be behind us really soon. We were all hoping this will be behind us quite some time ago, but it's been going on for months, and hopefully we can overcome this terrible situation and move forward. Thanks to all the sponsors helping organize this event, especially C Sharp Corner and the Tech Platform that are running this event, but also all other sponsors helping the cause and making this possible. Let me tell you a few things about myself. I'm a solution architect at Authority Partners. I'm coming from Bosnia and Herzegovina, but I've worked for an American company and for American market. Here is also my Twitter handle. If I can be of any kind of assistance to you, if I can answer some questions, please try to reach out. I've been Microsoft Azure MVP for 5 years now. Just received fifth award a few days ago. I'm also very certified in Microsoft technologies, have over 50 active different certification, and so I'm Microsoft certified trainer for since 2012, Microsoft VTSP, and so on. We won't count all of them; it will take too much of our time. But anyway, let's discuss DevOps and what it means for software market, what it means for software developers and software development companies, and where that leads us. But before we start, let's discuss how we deliver software in the past. How was it done before everything that we do today, all the fancy tools and everything else? So a long time ago, like 40 plus years in the past, we have punch cards. And this was actually the way we deliver software right back then. This is even before my time. I'm quite long in this industry, but even myself don't remember this kind. But let's be honest. Like this was something that was used to deliver software, and people even managed to land a rocket on the moon using this kind of software. It might look primitive to us, but it could do amazing things, and we could actually do software with it back then. A bit later down the road, we had floppy disks. They were big step forward when it comes to software delivery, but compared to today, they are quite limited. They had approximately 1 megabyte of free space, and that was basically it. I remember back in the days when you wanted to like install operating system, we had to use like 20 or 30 or even more of these disks, and there were there were unfortunate events when you like failed to insert disk 26 and had to start all over again and that sort of thing. But compared to the punch card, it was a big step forward. Very funny thing, like a guy a few years back said he showed the floppy disk to his daughter, and she said, yeah, she thought that it was 3D printed save icon. The new generation nowadays don't even remember these types of software delivery. But as I said, it was something big back then. Then there was something called computer magazines. This was something from my home country back in the late 80s or early 90s. And they had different types of software delivery from day one. So I remember the early stages of it when you had actually code printed out on the pages, and the way you could actually like use that software, you could run it on your machine was actually you had to type it in on your computer and then compile it and then run it. That was basically the first type, first way of that kind of software delivery. Computer magazines then evolved and started including floppy disks. I remember the days when on the single floppy disk you had like 7 or 8 different types of software already prepared. You could install. So on 1 MB you had like 7, 8 different applications. It was quite amazing. Later down the road, computer magazines also started including these optical medias. This was a big step forward from 1 MB. We all of a sudden had 700 megabytes CDs, 4.7 gigabytes of memory on DVDs, and even more on Blu-rays. It was a big step forward when it comes to software delivery and what we could like deliver on this piece of media. But everything changed with web. Web was the big impact, made a huge impact on software delivery and how we could actually deliver software. It didn't require any type of media anymore, because I said I'm very long in this industry, and like I remember when you had like 20 years ago when we did a new version of software, what I had to do was I could actually copy it on something like
Hi, are you there? Mustafa, are you there? I think we
hello.
lost you for a couple of minutes, like couple of seconds. Yeah. Go ahead.
Okay, perfect. Yeah, but we're good now, right?
Yeah,
Can
yeah,
you
yeah. Go ahead.
see my screen again?
Yeah, yeah. Go ahead.
Okay, okay. I don't know what happened. It just said it was dialing me back in. Okay.
Yeah.
So as I said, I've been in this industry for quite some time, and back in the days, like 20 years ago, we had when we did a new version of the software, I had to copy that new software on something like either disk or USB stick or something. I had to jump in my car and drive to each of my customers to deliver new version of the software. Web changed that significantly. A web change, how we could uh, um, update software, how could we distribute it, even sell it. So using web, all of a sudden we could like sell copy of the software over the internet. We didn't have to even visit customer to do installation anymore. We had the opportunity to send out new versions, new updates over the internet. It changed how we do software significantly compared to the previous one. But last 10 years, we had an increase in something called cloud computing. And you probably all seen this slide many times over the last few years, comparing different types of cloud computing, from infrastructure as a service, platform as a service, software as a service. But what mostly impacted, like all of those did an impact on software industry and how we do it, but the major change in software industry was software as a service. All of a sudden we had to rethink the way we did software. There was not like in the past we sell software as a package. We spent a certain time developing it, and then for a relatively long amount of time we will probably sell that copy of the software, that version, then we would like work on a new version and so on and so on. I find perfect example of software as a service and how software as a service changed things in Microsoft Office package. So in the past, we had different versions from, I don't know, 2000 to 2013, 2016. And these were like delivered in 3-4 year cycles where you have to spend a long time developing something, betting that you had made right decisions, right both business and architectural decisions, and that all the features and everything that you want to deliver will be relevant after the software is released. So when we compare the market today, things are shifting very rapidly. We don't have like that much time to adjust because let's say that we are that we are going to work on a certain software, we are going to develop it for next 3 years. So decisions we make today, if you're starting out today, we're starting out in 2020 and we're going to develop it for 3 years. We're going to make some design decisions, feature decisions, and so on. And after 3 years, when we deliver it, we are betting that all the decisions that we made in 2020 are going to be relevant in 2023. That's a really long shot. Market is changing rapidly. There are multiple products doing similar things like you do. And there's a big probability that most of the things we did 3 years ago will be obscure in 2023. So basically, software as a service changed the approach about it. It also changed how we deliver software. We're not selling it as a package where a client has to invest certain amount of money, and it's probably going to get stuck with that piece of software for quite some time because it needs to be financially justified before changing it and so on. With the software as a service, we shifted to subscription model where we are selling our clients monthly subscription, and we have to be new, we need to be fresh, we need to be innovative and provide the best possible experience to our customers. Why? Well, basically because they are not stuck in with us. They didn't invest huge amount of money. They're paying for monthly subscription. And if we are not offering the best service, by the end of the month, they're going to switch to our competitors. And basically, all of us have competitors. It doesn't really matter which industry, which niche are you targeting with your software. There's always someone offering similar product. Or if it's not today, it will be tomorrow, but there's always competition waiting for us to slip up. But what issues we have in this IT industry and to make this work, how can we actually provide this best experience for our customers? First one would be definitely traditional issue in development and operations. So in traditional IT environments, development and operations are two isolated sub-organizations inside our organization that don't actually work together. They don't actually communicate. They don't actually try to resolve issues together. They are totally separated, and in many cases, they are actually acting as there's a war going on between those two departments. So why does it happen? How does it happen? So basically, there's something often referred as fall of confusion between development and operation. Development is all about providing new things, about change, about experimenting, about trying to make things fresher, newer. On the other hand, operations are all about stability. They're all about keeping things functional and maintaining them running as smooth as possible. So this is the main reason why they sometimes act as opposing side. The other thing that is missing is in their work is definitely more communication, more contribution, more bringing people together to resolve things and understanding each other's points of view. So there's often this we or them approach when you talk to developers and operations. Like I have a long system engineering background, and I come from ops side of the things. And if I had $1 for every time I heard it works on my machine, I would be a really, really, really rich man today. Basically, you're gonna hear those type, and these might sound like stereotypes and not really convincing, but these things are actually happening day by day. I witness them over and over and over. So developers will always say it works on my machine, it's an issue somewhere else. On the other side, operations will always say it's not my server, it's something in your code. But let's say that we have a certain situation. If we have like 6 days after successful development, service suddenly experiences high load. Who is responsible to resolve this issue? Is it devs or ops? Well, it actually depends on who you're asking. If you say, if you're asking a developer, they're always going to say, no, it was 60 days ago. It's something on the server. Like if it was a code, it would like probably be from day one. It wouldn't like wait for 6 days for issue to occur. If you ask operations on the other side, they will always say, yeah, my servers was running fine for years. All of a sudden they deployed something new on it and it's stuck. It's definitely code. When you have a different situation, when you have like software is deployed to test environment and you cannot log into application, who is responsible to resolve the issue? Is it DevOps? Again, same thing. It really depends on who you're asking. Dev will say it's ops, ops will say it's dev. Or we have a situation where with the build server, the code simply doesn't build. Who you're gonna ask? Developer will say it's operation. Operation say it's development. It's always a blame game going on. It's always that kind of issue. But those are the big problems today. Like in traditional IT environments, there's no formalized handover between two teams. It doesn't really, it's not clear whose responsibility is what. Operations are always facing problems in production and development that usually doesn't even have access to production. They work as a silos, isolated organizations, like there's no teamwork involved. I also already mentioned development is about new things, operation is about stability. They use different teams. They have total disinterest for the other team, even a hostile attitude toward other team. We very often have different environments in dev, test, and production. People that are maintaining those environments are totally different. Those environments have totally different configuration and so on. As a result of that, we also have a blame game going on. Everyone telling is the other side responsible. We have different processes that our teams working by and so on. But as a we can go deeper into this analysis and look, but main reason for dev and ops issues is lack of communication. Very often, like development doesn't really have no clue what the production environment will look like. What are the servers there? What is the operating system even, or and so on, so on. So they don't have any insight in the production environment and how it's running and what is the structure. On the other side, operations really don't have an insight on what is being developed. Are there any special requirements? What is there any special software libraries, frameworks that need to be set up, and so on, so on, so on. So in this situation, it's basically development works for a certain time or something isolated on their own, and when they are done, they just like throw that over that wall of confusion to operation side, and they're like stuck with maintaining it for the future. They have no idea what's gonna, like dev doesn't have any idea what's gonna happen to software in the production, and ops actually don't have any idea what is developed in the first place, what is the expected behavior and so on. So in this kind of isolated environments, situation, we have a problem with lack of communication, mistrust between the teams, and that often resolves in this blame game where the biggest impact is on the end user, because whatever issue we have, so when we have this situation where something is going off in production and application is not being available, while we're trying to find who is responsible, the end user is suffering because they cannot use our application. They cannot use the software they're paying for. And that is a really, really, really bad situation. And what is the solution for these issues? Well, definitely it's DevOps. And DevOps is kind of a vague thing, and whoever you ask what DevOps is, you're probably gonna get different definition. So for different people, it's a lot of different things, and the probably best definition I found so far is by Donovan Brown from Microsoft, who says that DevOps is the union of people, processes, and products to enable continuous delivery of value to our end users. It's maybe not perfect. DevOps is so much more and can be discussed as a lot of different things. But this is the probably closest thing we can get in a single sentence. If you're looking for like textbook definition, I think this would be the closest one that we can get. So basically, there's a lot of confusion. In the past, I often run into DevOps engineers. I really hate that term. It's not about like a single person in the organization that's going to deliver DevOps to you. It's union of people, like both dev and ops sides have to come together and work on it. It's about processes, and there's no silver bullet here. It's not like you have to do these 3 steps and you're DevOps. It's about adjusting your current processes, your current needs to reflect those changes. And about products, basically we can use many different things, many different tools to get the end goal. Basically tools are the secondary thing. They're in the background of the story totally, but needs to be considered as well. But the main focus of us would be to enable continuous delivery of value to our end users. And that is the most important thing, both from the DevOps and from software as a service perspective. This is the most important part of the story, continuous delivery of value to our end users. That's what we need to focus on. Okay, so DevOps is primarily a totally new culture and new way of thinking. As I said, there's no silver bullet and there's no textbook definition. Like you have to do these 5 steps and you will be DevOps. I've seen many times that especially on the C level, people will go to a conference, discuss DevOps with people, and they will return from the conference, say, from today we're DevOps. It doesn't really work that way. You have to adopt new culture and start a new way of thinking to actually achieve it. It's a long way to do it. It's not easy, but it's rewarding in the end. First thing about DevOps is that we need to understand that we have to automate everything. That's the rule number 1. There are many different tools in DevOps ecosystem, like many different. My personal weapon of choice is definitely Azure DevOps. I've been working with it a long time. It can integrate with basically any other tool, any other platform. But this goes along for probably all the tools out there. We can, it depends on what we're developing, what are we working on, what are our requirements, what is our background, what kind of people we have available, and so on. But the key to DevOps is to automate everything. Why? Because most of the issues in production I've seen in the past have been because of the human error. It really often it happens that someone just if application after deployment is not working, it's because someone copied the wrong thing somewhere, and the connection string from there ended up here, and this part of code shouldn't be really in this version, it should be in this, and so on, so on, so on, so on. So we want to eliminate that probability that we'll just like manually mess up something. We need to have defined steps and try to automate them as much as possible. That is the first rule. We also have few terms that we have to understand, like continuous delivery, continuous integration, and continuous deployment. Continuous integration is basically refers to building and testing your code within the development environment. It's basically some first validation that code is valid and should be operational. But on the continuous delivery and continuous deployment, it's basically about putting out the release. But the big difference between delivery and deployment is that basically deployment should be automated from beginning to the end. Basically, continuous deployment would be running automated tests and pushes across different environments, and basically getting code from like a push to repo to production without any human interference. On the delivery side, we still want to automate most of the things, but with continuous delivery, we probably want some kind of human approval and someone to allow something to be deployed then and so on. It's basically mostly used in environments where we want to avoid deploying things in like high loads time, peak hours, where our business is really dependent on our software and so on. This chart is very interesting to me. When we look at it, we can see some companies are doing amazing work when it comes to deployment frequency. So basically, Amazon today is doing 23,000 pushes a day. Google is doing 5,500 a day, Netflix 500 a day, Facebook 1 per day, Twitter 3 per week. And when we look at the typical enterprise does a deployment every 9 months. This really tells us how slow can some organizations be in terms of changes and adopting DevOps. We have to understand that probably, not probably, for sure, the amount of things we're gonna have deployed in Amazon in a single deploy cycle is going to be like minimum. On the other hand, things that are going to be deployed in enterprise in 9 months are going to be huge. We're going to deploy 9 months of work in single action. This will bring additional issues for us, and DevOps is also a really good solution for it. But let's come to that in a second. Let's discuss project execution, the methodologies. So in the last few years, most of the companies adopted either waterfall or agile, where we basically did design in the beginning and deploy at the end. Design, it is something in common for both. We basically do planning and decide what we're going to do in the next period of time. And in waterfall, we're going to code everything, like do a development part. Then we're going to, once everything is done, we're going to test everything. And after the tests are done, we're going to deploy. In agile, basically, we do chunks of code, we do tests on those chunks, and basically when everything that is planned in the beginning of the sprint of the period of time, when everything is done, both coded and tested, all those chunks are put together and then deployed. For the time, these were accepted methodologies, but additional problems occur. Especially when we look at the previous slide where we had like those deployment frequencies, especially when we look at those 9 months of deployments as well. So basically what we get is a bunch of code that is deployed at the end of those months. DevOps addressed that issue and another one. In DevOps, we still do a design, but the difference between the previous methodologies is that basically we do code, we do test, and smallest testable chunk of code is deployed to production right after it's being tested. So basically, we are trying to divide everything into small chunks that are functionally independent. And basically, once we do that, once we do the changes in the code, once we deploy something new, we immediately test it. And after, if it passes all the tests, we automatically deploy it to production. We don't anymore wait for a long period of time. We no longer wait for 9 months to pass to actually deploy something. We deploy small chunks of code. There are two issues that this is addressed. The first one is the amount of changes. When we deploy our code after 9 months, that is a lot of changes, especially when we're discussing enterprise. It's a lot of people working on those teams, and it's huge amount of code deployed after 9 months. And we're always going to have bugs. It's impossible to avoid them completely. We're going to have issues in our software, and we need to resolve them fast. When we have 9 months of code deployed in the single action, we need a lot of time to address those issues and find what the issues are, what the problems are. It will take a lot of time to actually resolve them. On the other hand, when we have small chunks of code that are deployed at a time, we can easily pinpoint where the issue is because we need to look at the small chunk of code. We don't have to look at the 9 months of code. We are looking at few hours or even less of code in those deployments. So it's much easier to track that issues. One of the problems that this also resolves is the value for the customer. When we deploy 9 months of code to end users, they're going to get a lot of new features. When the issue occurs, we're going to do rollback, remove all those new features, even the ones that are working properly. We're going to roll back everything, try to resolve issues, and then deploy again. We don't have that kind of problem with DevOps because we are just removing small chunks of code, small functionalities. It's usually a button here, button there, new menu. Sometimes these changes are bigger, but we are only removing one thing at a time. We're rolling one thing at a time. Another thing that this approach is addressing is basically keeping up with our competition. At the beginning, I mentioned that software as a service changed how we do things, how we manage things in our environments, and how we manage customers now, because they are not locked in with our product anymore. They're paying for subscription. They can cancel at any time. In those kind of environments, when we have to be on top of our game and provide the best possible experience to our users, because if someone else is doing a job better than we are, they're going to switch to our competition. They're gonna leave and start paying for a new product. Well, with DevOps, we can provide value soon. Basically, if we like doing a small change, we don't have to wait for 2, 3 weeks, 5 months, or whatever to deploy changes to our customer. Any change, any improvement that we're doing, we can provide them that improvement immediately. It also refers to keeping up with the product value, because if we develop some new feature and we're waiting for a long time to actually release it, someone might be there before us. Someone else is maybe developing something similar, and they're going to beat us to market. They're going to offer that to our customers before we actually do. We have to basically provide new value as soon as it's ready. Same thing goes with catching up with the competition. Basically, if we are coming into the office on Monday morning and we see that our competition has this new shiny feature that we don't have, we have to catch up as soon as possible. We cannot wait for months to actually deliver that. If we want to keep our customers on our side, we actually have to have same feature as soon as possible. So that's another part of this deploy frequency and how it addresses multiple issues for software development. But couple of things that we need to observe in DevOps. It's basically a never-ending cycle. So at the beginning of each cycle, we're going to do a plan. We're going to discuss, okay, what we want to do, what is the outcome that we want to have, and so on. And after we create the plan, we're going to start development. We're going to develop and test. After everything is basically each chunk, after it is developed and tested, we're going to create a release. We're going to push that to a production, and once it's in the production, we're going to monitor and learn. And when it comes to monitoring, it's a bit different in DevOps than traditional IT. In traditional IT, monitoring would be like availability, utilization, and so on, so on, so on. Monitoring in DevOps goes a bit further. It involves a lot of user metrics. It's about what features are our customers using. If we develop something new, are the customers getting to it? Are they using it at all? If they're not, why they are not? Is it hidden in some under menu, or they basically don't like the feature, and so on, so on, so on. So basically, based on both monitoring, both utilization, performance, and stuff, but also user monitoring, we learn, and based on that learning, we start to create a new plan for the new cycle, how to improve ourselves. So basically, it's the never-ending cycle that pushes forward and forward to be better and better and better and work on ourselves. Another thing that this approach does, this frequent deployment, these small chunks of code, these fast cycles, is increased feedback. Basically, it's usually business is providing certain things, then development is trying to create value that business is requiring, then it's pushed out to operations to push to production, and then it's offered to our customers. But this way, in this cycle, the feedback from the customer to the business is getting faster and faster and faster, because we're monitoring everything, we're trying to track all the changes, and we are getting the information. If something is good, we can measure that something new feature is actually providing real value. If something is not good, we can also catch that early and decide, okay, this is the wrong direction. We should not be going invest in this anymore. We should refocus and try something else. So DevOps is also giving us increased feedback that usually takes a long time for customer voice to actually reach business. We can increase this cycle and increase feedback frequency and speed as well. Also, what is really important in this cycle is experimentation. So basically, what should we do? How this, because it's a never-ending cycle, it goes on and on and on. So basically, when we start with something, we try to experiment. Does it work? Metrics provide us those information. If it works, yes, lesson learned, let's start from the beginning. But if it's not working, we again have certain lesson learned, and we again start from the beginning. And basically, whatever we do, we get feedback immediately. We're trying things, but we are trying to measure them and find out what is the outcome of those actions or of those changes that we're making. And based on those, we can learn and start new ideas and new plans immediately. What should we do to actually get DevOps into our organization? One of the things that we need to do is reorganize, restructure, change the way of thinking. The teams should use the same tools. People across our organization should adjust to similar tools, whatever those tools are. We have to pinpoint some, because I already mentioned in the beginning, different teams, especially when we're talking about traditional development and operations, not only use different tools, but different methodologies as well. We need to adjust to new methodologies. We have to change our tools and try to work together. Also, very important thing about DevOps is understanding MVP aspect. Done is better than perfect. If we are trying to create a perfect software, we're never going to deploy it. If we're trying to get something ideal, something that works flawlessly, we will never be done. There will always be something more that we can add. In DevOps, MVP is very important aspect. And I'm not talking about most valuable professional here. I'm talking about a minimum viable product. So basically, MVP is our baseline. Once we're done, so basically we need to get it into the state of done. We need to define what the MVP is, and then have it released, have it available to our customers. Because only then we can implement the DevOps cycle, where we can actually monitor and learn things. Because until there's an MVP, we're just like developing. But when we actually have an MVP done, then we can start releasing things to production, and then we can monitor things and learn what we need to do next. So basically, that's very important aspect of it as well. Some other things that we need to do to apply this to our organization. Start small. It's not impossible to do it overnight. It's simply not possible to reorganize, especially when we're talking about big companies. It's not possible to reorganize everything overnight and start DevOps. As I said, many times I've seen when managers come from some conference and say, okay, we're DevOps from tomorrow. Get me like 5 DevOps engineers and we're DevOps tomorrow. It doesn't work like that. Start small, try introducing small changes to people, because people are going to oppose change. It's a human nature. We're always opposing change. But if you start small and try introducing things and showing value in those things to your team members, they're going to start accepting it and be more open to change. So once those small things are showing them real value and how it's helping them to do their job, they're going to be more appreciative and open to accepting new things. Try implement end-to-end automation. It's a really important part. Try eliminating human error as much as possible. We need to build a culture that embraces the change. We need to be acceptable. We need to be adaptable, and so on. So basically, it's really a cultural change. Bottom line is DevOps is a cultural change, and we need to change the way we're thinking about it. Also, it's really important that it's all about teams. So try rewarding teams for the job well done instead of individuals. DevOps is all about the teamwork. We're always going to have top performance, but we should always try to build teams that are working together. And basically in DevOps, each win, each good thing is done as a team effort. So basically, there's if it doesn't really, with the DevOps, it doesn't really go with only Dev and Ops. It's much broader than that. So basically, it starts from, like, I don't know, sales. If sales doesn't do a pitch and sell this to someone, we're all out of jobs. But once the sales does a pitch, it's up to development to actually do it, to actually create some new value to develop a product. But once the development is done, if it's not pushed to production, it's never seen by our customers.
So basically, it's a change. We need to understand that everyone is working as a team, that it's a cycle that helps us to do things, and it's a team effort, and basically each good thing is a team win. It's also really good to have a common outcome-based dashboard so everyone can monitor and see our goals. They must be fillable. We must like see that we can do certain things and track down how much we need to achieve it. It brings up team spirit and everyone to work better together. Okay, so basically, all that's left, please provide feedback. I don't know if you have any kind of questions right now.